All right, guys, so moving on to our new lesson. We're still looking at triangles, but this time we're going to be introducing the triangle inequality theorem. So the way this theorem works is you are going to be given three sides, and basically what you want to know is it possible to make a triangle based on the three measures that you are given? So before we get into that, first thing we want to do is we want to define what the triangle inequality theorem is. So a triangle exists if the sum of the two smaller sides is larger than the third side. Okay, so I'm going to say that again. The triangle exists if the sum of the two smaller sides is larger than the third side. So now, of course, when we mean by sum, that means you're going to add the two small sides of the triangle. Now, no matter what the measure of that sum is, that number has to be bigger than the possible third side, okay? So when you add the two small numbers together, whatever you get, that number has to be bigger than the third number, okay? So, for example, if I'm given the numbers 8, 17, and 24, I want to know, is it possible to have a triangle that has these three measures, 8, 17, and 24? So the first thing I want to do is I need to look to see which of these three measures, which two are the smallest, okay? So looking at 8, 17, and 24, which two are the smallest? That's going to be the 8 and 17. So right here, these two are the smallest, which means in order for this theorem to work, I have to add these two numbers together, and then whatever their sum is, it has to be a bigger number than 24, okay? So if I do 8 plus 17, 8 plus 17 yields 25. So now, is 25 greater than 24? And it is. So that means yes, this can be a triangle, okay? The sum of the two small have to add up to a number bigger than the third. All right, look at number 2. 3, 3, and 7. So the two threes are the smaller sides. So if you do 3 plus 3, that gives you 6. So now the next question, is 6 greater than 7? In this case, no, it's not. So this is a no. This cannot be a triangle. And it's that simple, real easy. All you have to do is just take the two small sides, add them together, and whatever number you get, in order for it to be a triangle, that number has to be bigger than the potential third side. All right, number 3, 25, 35, and 12. So the 25 and the 12 are the two small numbers. So 25 plus 12, that gives me 37, which 37 is greater than 35, so that's a yes. All right, number 4, 52, 37, 42. So 37 and 42 are the two small numbers, so those are the numbers I'm going to add together. So 37 plus 42, that gives me 79, and then 79 is greater than 52, so this is a yes. Number 5, 28, 50, and 22. So 28 and 22. So I'm going to add those together. So 28 plus 22, that gives me 40, that gives me 50. So now this is a tricky one. Is 50 greater than 50? Well, 50 is not greater than 50. 50 is actually equal to 50. And the way that the theorem works, they have to be a bigger number than the third, not the same number. So this is actually no, this does not work. So 50 cannot be the third side. Got to be careful with that. It has to be greater than 50. Next, 6, 18, and 14. So 6 and 14 are the two small numbers. So 6 plus 14, that gives me 20. And is 20 greater than 18? That's a yes. So this is a triangle. 24, 12, and 11. So 12 and 11. That gives me 23. So 23, is it greater than 24? That's a no. So this is a no, not a triangle. And then finally 41, 7, and 35. So 7 and 35 are the two small. 35 plus 7 is 42. 42 is greater than 41. So yep, this is a yes. Very simple. So the theorem is quite easy. All we're doing is adding the two small sides together, and we want to see if that third side, if the sum of the two smaller sides is greater than the third side. All right, guys, so continuing on. All right, so the next thing we're going to be doing is now we're going to be looking for a range of possible measures that a third side can be when we are given two sides, okay? So now remember that we are looking for the third side of a triangle. So when we're given two sides of a triangle, you can set up an inequality using the sum and difference to show a range of possible lengths to the third side. So now that means is not only are we going to be adding these two numbers together, we're going to also be subtracting them. So now by subtracting the two numbers, that gives us our minimum value that the third side can be. So now there also needs to be a minimum. Then of course, when we add them, that shows them the maximum number that it can be. So the way it's going to work is, I'm going to do it over here on the side, is you're going to set up a compound inequality that looks like the following. You're going to have x be the measure of the possible measures of the third side. And then you're going to set up a compound inequality like this, where these are less than signs, where x is greater than this, and then x is less than this. So I'm going to use the letter A. A is going to represent the difference, which means that's the number you're going to get when you subtract the two numbers. And then I'm going to put over here, I'm going to put B. B is going to represent the sum, which means this is when you add the two numbers together. So A is when you subtract, B is when you add, and then whatever two numbers you get, that is going to be the numbers that x is going to be in the middle in the compound. Okay, so number 9 says, if you're given 14 and 22, what are the possible range of numbers that x can be to make a triangle? So the first thing we're going to do is let's get the difference. So the difference means we're going to subtract. Now, of course, remember, when you're subtracting, we're going to want to do the big number minus the smaller number. That way we'll avoid getting negatives. So if I do 22 minus 14, this is the difference. So 22 minus 14, that's going to give me 8. Then I'm going to do the sum, which means I'm going to add the two. 22 plus 14. That gives me 36. So my range of values that x can be for the third side of the triangle has to be between 8 and 36. So you're going to write your answer like 8 is less than x is less than 36. Okay, so these are the possible values that the third triangle can be. So anything greater than 8, so like 9, 10, 11, 12, all the way to numbers less than 36. So 35, 34, 33, and so forth. So if I were to give you, like, can 20 be a possible third side? Well, yes, it can be, because 20 is in between 8 and 36. If I say, well, can 7 be a possible third side? Well, 7 is not in between 8 and 36. 7 is on the outside of 8, so no. Same thing if you were to go above, like, can 40 be a possible length? Well, no, because 40 is not in between 8 and 36. And that's basically all you're doing. You're just going to be subtracting the two numbers to get the minimum number, and then you're going to be adding the numbers to get the maximum. Okay? All right, so same thing. If I do 31 plus 8, or let's do the difference first. 31 minus 28. That gives me 3. And then now let's add. It gives me 59. So my range of values is between 3 and 59. So I'm going to do my compound. 3 is less than x is less than 59. So that means all the numbers in between 3 and 59 can be the third side. Very simple. So of course, if you want to show your work, you can. I mean, it's quite simple, just some simple subtraction. So 11 minus 3, that's going to be 8. 8 plus 3, that's going to be 14. So my range of values is going to be between 8 and 14. Right here. 45 minus 19. So 45 minus 19, that gives me 26. So my range of values is 26 is less than x is less than the sum. 19 plus 45 is 64. Very simple. All right, 24 minus 7 is 17. 24 plus 7 is 31. So my range is between 17 and 31. 17, 31. 8 and 17, so 17 minus 8, that gives me 9. 8 plus 17, that gives me 25. So my range is 25 and not between 9 and 25. So 9. Very simple. So just simple subtracting and simple adding. That's all we're doing. Whatever numbers you get, the possible values is in between the range of numbers. All right, so let's do a multiple choice one. It says, if a triangle has a length of 15 and 27, check all of the possible lengths for the third side. So same thing. All we're going to do is find the difference and the sum. So if I do 27 minus 15, that gives me 12. If I do 27 plus 15, that gives me 42. So my range of values are between 12 and 42. So all I got to do is just check the boxes that are in between 12 and 42. So 34 is in between. 12 is not, because it has to be greater than 12, so this is a no. 29 is in between. 18 is in between. And 43 is not, because 43 is outside of the 42. So only these three. All right, then the last one. If the triangle lengths are 45 and 9, so 45 minus 9, that gives me 36. 45 plus 9, that gives me 54. So my range is in between 36 and 54. So we're just going to check all the boxes in between. 35 is a no. 48 is a no. 47 is a yes. 54 is a no, and then 39 is a yes. Right here. Very simple. Simple subtracting to find the minimum, and the simple adding to find the maximum. So everything in between.